Okay, I want to talk briefly about one odd thing with one-wire transmission of power. There's lots of strange things, and we'll just talk about one of them here today. So what we're looking at, and I apologize for the mess, what we're looking at is the circuit from a USB plasma ball. Runs off of a USB port, and just like 4 screws, and you pull it right out. And you get the one wire that makes all the nice sparkler effects in the normal plasma ball. And so I have it plugged in here to a USB port, and I just cut a wire there to get an amp draw. And then this wire here comes around to here, and it's plugged into a little bus line there, and there's 2 diodes. This thing doesn't focus in real well, but the 2 diodes are facing in opposite orientations and are going to the negative and positive of a capacitor. That 2 diodes in opposite orientations is the well-known Avraменko plug. Although when you fiddle around with it for a while, you can see that conceptually it's identical to what Bedini described, and I believe that Bedini did this before Avraменko. He was doing it, to my very limited knowledge, with bridge rectifiers, and again coming off of a pulsed inductor. But the idea is the same, and it might, in fairness, be called the Bedini-Avraменko plug. So we have the plug coming into the capacitor, and we'll hook up a voltmeter to the capacitor. The capacitor is full, so I need to discharge it. Just a moment. Okay, so I've discharged the capacitor. We have our little voltmeter and set at 25 volt scale. We have the probes hooked up, and we'll turn this on. And we can see power flowing into the capacitor. Again, nothing earth-shattering here. This is the simple one-wire transmission that's been popularized through the Avraменko plug. Okay, so now what I've done is just thrown another capacitor in here, in line with the positive of this capacitor. Doesn't matter which direction this capacitor is which orientation. You could have it going from positive to negative, or from positive to positive. We'll try and demonstrate that in a moment. And then I have another line coming from the opposite end. So down here you have the positive, and then from the negative end of the capacitor there's a line coming up here. And then I just put in another Bedini-Avraменko plug, and the reason why I'm doing this is because I've actually shocked myself through a capacitor, and I said that can't be what's going on, and so I wanted to look at it a little bit more formally. Okay, so now let's set up the next part. Okay, so we have this hooked up again, and we got the one wire coming in through the Avraменko plug to there, and then to here, where there's now this capacitor here, and there's the positive, here's the negative end going to here, to another Avraменko plug to this capacitor. And let's turn this on. And you can see we've got a 25 volt 470 microfarad capacitor that's charging right up. So that's really about it. It's pretty strange. Let me discharge it, and we'll flip the capacitor. Okay, I've now flipped this capacitor around, so now the negative is down here and the positive is up here. And I discharged this terminal capacitor, and we're going to go ahead and see it again. And there it goes. So that's pretty much the peculiar thing there. I can say that I've also done it with a diode, and the diode will slow the rate of charging in the terminal capacitor there, but it's independent of the of the orientation of the diode. And again, with the capacitor, the whole point of the capacitor is to separate charge. And you keep the hot side hot and the cold side cold, and it flows right through it like it's not even there. It basically treats it like another piece of wire. Now, one thing I wanted to check, and I did check this, and we'll demonstrate that next, is maybe it's just wireless. So let me discharge this capacitor, and we'll do that. Now we've got the capacitor, wire here, and then a wire just two above it with the space there, just an air space, and we have the terminal capacitor here, and we'll flip it on, and you can see it does charge it. This is some of that wild wireless stuff going on, but it's far, far slower. When the capacitor was there, it treated the capacitor basically like it was a wire. So just want to, so I don't really have an answer for this. The two options that I can come up with are both kind of interesting, and the first being that our current model of electricity is wildly off in ways that we don't understand. And the second option, which I find more palatable, is that what's flowing through that wire is not actually electricity. And that would explain some other findings too. That explains why that Russian group was able to transmit, I don't know what it was, 5 kilowatts, 50 kilowatts of power through a wire that was thinner than a human hair, and without any burning of the wire. It doesn't explain why I got shocked through the capacitor. It's still puzzling about that one. But what it seems to be is that there's a form of energy, and I suspect that this is the negative energy that's often talked about, although the terminology isn't defined yet, so I don't know what people are talking about, and I don't know if people who use these terms are always talking about the same thing. But somewhere between 60 to 90% certain that this is what people are talking about when they talk about negative energy. Okay, again, so just to wrap up, I don't have any answers here. What my best guess is from the evidence that I've seen here is that what is flowing through the wire in one-wire transmission of power is not electricity. However, it can be transduced into electricity through the intermediary of diodes and capacitors. And that's about all I know, and it's hard to even be certain if that's correct. All I can say is it's pretty weird. So we'll leave it at that, and I hope people enjoyed it.